Well, hello everybody. Thank you for coming back. I appreciate the support that I got on the last video, and I wanted to make another one for you. And I really like C++. That's what we're gonna do today, because that's what I work with, and I like to program my own projects in C++. So I think I'll kind of go like back and forth between like higher level, lower level. Um, there we go. Types of videos. So today I wanted to kind of go over like how do smart pointers kind of work and how do shared pointers specifically work, because I was kind of interested in that, and I was kind of like, what if I made like my own, just to try to like figure it out. So that's what we're gonna do today. There's gonna be a lot of C++ principles in here, so hopefully you guys learn something. Um, but let's go ahead and get going. As always, we're gonna start with the kind of header guard right there, and so I'm just gonna call it a ref pointer, because it's a reference counting pointer. That's how it works. So the idea of a shared pointer is that you can send the pointer around, and then using C++'s RAII, or resource allocation as initialization, or whatever it's called. Once everybody's done, once the pointer goes out of scope, however many times it was like used in scope, it will then delete itself, which is pretty handy. It's my favorite smart pointer. I use it a lot. So what do we need? What do we need in here? We need the reference counter. Right. So this is what we're going to be passing around, to make sure that once this reaches 0, we make sure that we delete the resources that we've allocated, and that's going to be this right here. And T is some type, so we need to make sure that we template the class so that we can have some sort of data in here. So actually, most of the time when these things are called, I'll actually go ahead and pointer class right here. And I guess while we're at it, let's get IOStream in here so we can do some printing. Right, so we can make sure that this works. Once again, I will be using GCC or G++, and that's working, so good. But the way that what is it? Memory? Yeah. So the way that shared pointers are usually created, and I keep getting ahead of myself. Let's have an example structure, I guess. We have a person with a name and an age. And just for the sake of this, we're going to have a constructor. So we would have some shared pointer of type person. We can just call that me. And what you're supposed to do is you're supposed to call make shared. Right, and we have this right here. And so we can come in and we can set the name to my name. We can set the age to my age. And that's all good. And so we can pass this around, and ideally in another scope, we can have some copy of me, right? And so we can adjust things here, right? So let me just do a really quick goodbye. For those of you who aren't as familiar with this whole setup here. And let's have some hello function here as well. I'm name, I'm age, years old. There we go. Getting to the end of the screen over there. Just so we don't have to keep printing things a whole bunch. We'll do it one more time. So the idea here is that do I have to put it in here? Yeah, there we go. All right. So yeah, so look at that. So the idea is that we get like a copy of this pointer. So you could like send this to another function. It would be a pointer to this information, but we never have to call delete. So which is where most memory leaks happen, is in delete or free or whatever you're most used to. And so this is really helpful. This is a really helpful way in C++ to use pointers without worrying about deallocation. Yeah, cool. So we're going to replicate this behavior ourselves. So let's have a default constructor where mref is 0 and mdata is null pointer. And let's have a constructor where we get some information. Actually, I should call that pointer, shouldn't I? Because it is a pointer to data. Right, and over here, we actually do need to do something. So we'll actually set mref to 1, because we do have technically now one reference to this data that we're getting. And actually, do I need to... can make this the same as up there, I think. I know I look like an idiot when I'm constantly looking down. Alright, so these are kind of our two base cases. We'll have a ref pointer that's kind of empty, and we'll have a ref pointer with data. And then the important part is the copy constructor, not that. Again, looking at notes, I don't code on the fly very well. So a copy constructor, we'll get to that in a second, was before right here. So we have a new shared pointer of a person right here, and we're setting it equal to this. Just that's the we're calling the copy constructor here under the hood. So how do I do that? There we go. So we need to kind of hook into that really quick. I don't think this actually... I'm pretty sure this is the way you're supposed to do copy constructors. Although I guess it doesn't really matter, because if you're making a new one, it can't be the same one you made earlier. So we're gonna do... the pointer is the same as the copy that we're receiving, or the original one that we're receiving, rather. And then our reference counter is going to be the same as that one, and we're actually just going to increment that number, because now there's another copy that we need to keep track of. So I'm just going to do some comments. This is the copy constructor. We'll also have the copy assignment operator as well, but I'll do that in a little bit. We also need to have the destructor, because here in our destructor we need to decrement this reference count, because that would mean that this is going out of scope. So I'm just going to leave this up here. So when this shared pointer goes out of scope, once it reaches the end of this block right here, the destructor is called, and the reference counter is decremented. So we want to mimic that behavior. So we will decrement. And then if we're the first one, if we're like this one right here, and we go out of scope once this main function is done, we want to make sure that then our reference count would be 0 by the time that we get past this point right here. Because notice it's 1 right here, and then when we come over here, it's going to be 2. Then when it leaves here, it's going to be 1 again. And then when it exits out of here, it's going to be 0. And when it's 0, we want to delete the pointer. And just to be clear, I know that I know what I meant to say when I started, which was I was mostly going to comment on this make shared thing right here, and I'll get to that in just 1 second. We will be allocating all the information for this pointer right here, and I can kind of come down here really quick and show you what that looks like. So we're going to do a slightly different version right now, and then I'll show you the cool version where we construct it kind of like in line almost. So we're going to want to have a ref pointer here, and that is me. But we want it to look like this. I'm actually just going to have a person here. And so we're going to just kind of take that copy right there. We're just going to kind of copy this stack allocated one. Yeah. So we need a static function here. We're going to call this make. Oh, that's not it. It's not a member of the thing. Sorry, it will return a ref pointer. We can just call this make ref, and it'll take a copy of that data. So now that's defined, so it'll take this copy right here. And we're going to construct a new version that will do it will call the copy constructor of whatever this is, which ours is the default copy constructor, which will work fine because we only need a shallow copy anyways. So that's fine, so we don't need to write a custom copy constructor here. But note that if we did have something where we needed to do a deep copy, you would want to have your own copy constructor, because that would be called right here to get this pointer. And then we would just return ref pointer t. And so that's what this constructor right here is for, because we're passing a reference pointer with the new thing that we just created. And that's where this delete comes in, right? So we're creating a new pointer right here. We're deleting that pointer right here when the reference counter is 0, excuse me, which will happen when this comes out of scope. So we can kind of copy this again. I'll get this out of the way. So all we have to do here is just change this to a ref pointer, and it should behave exactly the same as it did before. And of course I did the example wrong. You know, because why wouldn't I? And why is it mad? Expression must have pointer type. Oh, I'm so dumb. Yeah. So we also, now that we're done with that, we need to overload a couple of operators. So first off, if we want access to the pointer itself, so if we want access to like its fields, then we need to overload I don't remember what that operator is called, but we're overloading it. And we just return the pointer, so this should work now. Perfect, look at that. All right. I'm going to go ahead and like run this one again as well. I'll just say I'll just comment all that out. That's supposed to be copy. Some of you may have caught that one. Come on. So let's hope. Yeah. All right. Yep. See, look at that. Same exact thing. All right. All right, so this is how we access the pointer's internals. If we want to access like a reference to the data like without the pointer, we can also overload the dereference operator. So we can just kind of dereference that as well. So yeah, there we go. So we could kind of like dereference it as well, which is handy in places where you would want to do that with a regular pointer as well. And then we can get the raw pointer as well, which is not always the best for these things, but you gotta do it. You gotta do it sometimes. So obviously this would like kind of break it a little bit because you're not reference counting anymore. But the regular the STL shared pointer has that as well, so we can add that just for good measure. Yeah, so that's kind of it. That's most of it. So this works now. Let me try that again. Oh, because it needs... It is a reference. And really, while we're at it... You know, let's just do that. And then we'll just increment it right there. What are you mad about? Cannot bind non-const L value. Ugh. You know, I thought I was cool for making that a reference. But I guess in the end it did not matter. Right, so now we can't necessarily do that. Actually, yeah, we totally can. Alright, so this is going to be a pointer now, not a reference. As always, I go off script and things fall apart. So this is actually a little bit different now. As is this. Because we have to dereference it. But that should be it. Now we're in good shape. So it's calling goodbye for whatever reason. I don't like that. Oh, it's calling goodbye because it copies it over here. So if we don't want to copy it and we just want to what's called in place, we're going to do a fancy little argument pack, I believe is what it is called. So we don't want that because that's annoying. So we'll just do it like we did with the STL library, where we're going to do it kind of inline like this. Now, the way that we do this is, again, we need to provide the type that we need, but we also want to do what's called an argument pack. So we can actually provide just kind of like random stuff. I don't actually know how this works very well, unfortunately, but you can kind of provide like random stuff to it for constructor's sake. So we can have another make ref here. And then what we can do is we can pass these arguments to this function right here. We can pass all this crazy stuff. So we can just kind of pass like whatever, sort of like in a normal variadic function. And and then we can unpack them in here. So we can make a new T, but we unpack everything right here. So we're not copying anything anymore. That's why the goodbye was there, because it copied it into this, and then it like created a new one, and then once this returned, it called the destructor again. For like this local version. So that's why it was different. Now it will be better. Right, so now we can return similarly to how we did it up here. And then we'll have basically a carbon copy. Look at that. Look at that, exactly the same results. It's amazing. And then one more thing, just so we can. Let's see. We want to do the copy assignment. Right, so we need to have... Is that, yeah. So we need to return a reference to a ref pointer. And we need to take this thing right here. Copy, I guess. We can call it whatever we want. Pretty standard. This is where we need to worry about it. And we're actually going to need to do a comparison operator, I believe. Won't we? Yeah, we will. So, again, we'll copy the data, and we will copy the reference counter, and then we need to, again, do kind of a similar thing that we did up here. Increment the reference counter, and then we're good to go. We're good to go for the copy assignment. So we can do things like, instead of the copy constructor right here, we could do this. But we do need the comparison operator. So I'm going to just toss that down here. Let's see if I can do this from memory. I guess that should be called other, I guess. And I think we would just say if their pointers are not the same, then they themselves are not the same. So we would just do... we would just compare their pointer values, which should be enough to get this going. Oh. I don't know why. Is it not a const? I guess not. All right, look at that. Cool. So that's basically how it works. I hope. I feel like I kind of just like ran through this a little bit, and maybe that's the case. And if this was not helpful, I am sorry. I hope that it was helpful. I hope that you learned something here. But I hope that kind of makes sense, like kind of internally, like how that would work. Using C++ principles to make a shared pointer-esque sort of deal. I think that they also have some sort of like destroy function. So if you wanted to like kill the pointer before you got to the like out of scope, I guess, you could do that. So you could have like destroy. You'd have some destroy function that like it needs to make sure that the reference counter is still 0. Like it still needs to make sure to do that. I did not do that. So it needs to make sure that's 0 still, but then it can just delete the pointer. So we actually could just call destroy here, and then it'll do that check anyways. So like if we wanted, we could destroy it like right here, and then it would... Why? Okay, there we go. So and then it before we like technically like went out of scope, it's like we could do like some more things like goodbye, and like if we wanted it to be gone before the goodbye, we could technically destroy it. This is the last remaining reference to that pointer, so it would be fine to this would call it before goodbye. I guess I should do a person goodbye so I can show you that. Or not, you know, maybe it won't. Should we just do that? Because that would do it. How did I do it? How did I do it before? Yeah, that would never actually work, I don't think. Yeah. Okay, there you go. So now it would go away before it actually went out of scope. Which might sometimes be helpful. I believe that there is some sort of function like that in the STL for the shared pointer, but yeah, look at that. There we go. We have a shared pointer. We could pass that around to all sorts of different places, and I guess before I go, I can demonstrate that instead of just doing this easy scope right here. We could call it like a birthday or something. So this takes a ref pointer to a person. Right. Birthday me. Right, there we go. And just probably and that probably won't work. Yeah, we'll just send it over. Yeah, anyways. So then we could just do age plus. So it copies it over here. No, we're just passing this as like a copy, basically. We're not passing it as a reference or a pointer or anything like that, but it still has access to the pointer. That's not what I wanted. Where am I? There we go. Right, so it still increments the pointer for us through this birthday function, so we can like pass it over there. And I guess the most common use is for if you have like different classes and you want to have like shared data, you would use like a shared pointer like that. So anyways, I'm kind of rambling at this point. So thank you guys for watching. I hope this was at least interesting. I will try to do some more low level stuff as well, because I know you guys have been asking for that. So yeah, I hope you guys learned something and have a great rest of your day.